Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integration. And here we have an integral in which the greatest integer function is involved, right? So here we have to solve this integral from 1 to square root of 2, and the integrand is 1 over x, greatest integer of x square plus 2, right? So in order to solve this integral, we have to make use of the method of substitution, and then we'll make use of the definition of greatest integer function, right? So let us start. And here we can first take this integral as I, right? Now see, here the limits of integration are from 1 to square root of 2, right? And in the integrand we have the greatest integer of x square plus 2, right? So what we will do, we'll take t is equal to x square plus 2. So here we'll make this substitution, and we'll convert this integral in the variable t, and we'll also change the limits accordingly, right? So here x varies from x is equal to 1 to square root of 2. So here t is equal to x square plus 2. So therefore we can now write x square is equal to t minus 2, right? And x can be written as square root of t minus 2, right? Okay, so now we have x is equal to square root of t minus 2. So let us differentiate both sides with respect to t in order to get dx, right? So dx over dt is equal to d by dt of square root of t minus 2, right? And now here we'll make use of the chain rule also. So we have t minus 2 raised to half, and the derivative of t minus 2 raised to half is half. Then we have t minus 2 raised to half minus 1, and by chain rule we have the derivative of t minus 2, right? So this is half, and t minus 2 raised to minus half. So half minus 1 is minus half, and the derivative of t is 1, and the derivative of 2 is 0, right? So now we can write this expression as 1 over 2, and here we have square root of t minus 2, right? So dx over dt is equal to 1 over 2 times square root of t minus 2. So now we can write dx as dt over square root of here we have 2 and t minus 2, right? So now let us change the limits. See, here we have x is equal to 1, right? So when we have x is equal to 1, we'll take x is equal to 1 over here. So t is equal to 1 square plus 2. So we have 1 plus 2, that is 3, right? Okay, now when x is equal to square root of 2, then t is equal to root 2 square plus 2. So the square of root 2 is 2, and here we have 2, so this is 4, right? So when x varies from 1 to square root of 2, t varies from 3 to 4. So now let us rewrite this integral I as, see, when x is 1 we have t is equal to 3, so here we can write 3, and when x is square root of 2, t is 4, right? So we have now the integral from 3 to 4, right? And we have 1 over x, and for x we can write square root of t minus 2, right? And for greatest integer of x square plus 2, we can write the greatest integer of t, right? Okay, and for dx we can write dt over 2 times of square root of t minus 2. So now we can simplify this expression. We have 1 over 2 outside the integral, and we have 3 to 4, and we have greatest integer of t, dt, and in the denominator we have square root of t minus 2 times square root of t minus 2. So this is simply t minus 2, right? Okay, so now see here t varies from 3 to 4, right? Because the limits of integration are from 3 to 4. The lower limit is 3 and the upper limit is 4. So t lies between 3 and 4, right? So from the definition of greatest integer function, we see that when t lies between 3 and 4, then the value of greatest integer of t is equal to 3, right? See, for example, if t is equal to say 3.2, right, then the value of greatest integer of 3.2 is simply 3, right? And similarly, when t is equal to say 3.9, then the value of greatest integer of 3.9 is equal to 3, right? Okay, so now this integral takes the form half, and we have 3 to 4, and here for greatest integer of t we have 3, right? So we can write here 3 dt, and here we have t minus 2, right? So now we can take 3 outside the integral, so we have 3 over 2 and 3 to 4 dt over t minus 2. So now we have a very simple integral here, and we know that the integral of 1 over say x minus a is the log of x minus a, right? So we'll make use of this result in calculating the indefinite integral of 1 over t minus 2. So we have 3 over 2, and the integral of that is dt over t minus 2 is log of t minus 2, right? So here we have log of t minus 2, and the limits are from 3 to 4, right? So let us substitute the limits. So we have log of here we'll have t is equal to 4, so 4 minus 2 is 2, and see, when we have t is equal to 3, so 3 minus 2 is 1, right? And the value of log of 1 is equal to 0, right? So we have 3 over 2 log of 2 minus 0. So now I is equal to 3 over 2 log of 2, right? So viewers, the value of this integral is equal to 3 over 2 times log of 2, right? So we can also write this expression as log of 2 raised to 3 over 2, right? So by virtue of this property, that is n log m is equal to log of m raised to n, right? So this is how we can solve these type of integrals.